All right, so more of the same. There's patterns that emerge when we do polynomials. Up until today, we were doing cubics, or x raised to the third power. So now we're going to explore fourth power, fifth power things. Okay. So the first thing, basically, we're going to look at how many distinct factors there are. We're going to look at the x-intercepts. We're going to look at whether the x-intercepts are tangent or cross the x-axis. Again, we're going to look at how many turning points, global maxes and mins, just like before. Global and local max and mins. And so this first column is the same information we've been doing, okay? So I'll give you a second to write that down. Many of you guys, I was looking at the notes not for this class, but for the other class, they've had this long running list because we've been doing a lot of functions and just looking at the behavior of the functions as we change certain things. So while you guys are writing that down, over to the side, does everybody have a calculator first and foremost? You'll need a graphing calculator if you don't have one. What I'm going to do, I suppose, I don't like this, I try to make my head smaller, but I used to be able to change the size of the camera, but for some reason on this computer I cannot. I used to make it really tiny and put it off to the side. I have to put it right here because sometimes you guys log into the Jamboard and I don't want it to see your name. I'm sure you guys don't mind, but I'm trying to protect your privacy. Alright, so what I'm going to do is I'm going to graph. I see that you guys are still writing stuff down like a crazy person. I'll make this smaller. I'm going to go to y equals. I'm going to clear all this stuff out. And I'm just going to plug in x raised to the fourth. When you get a chance, if you could do that on your calculator, that would be awesome. I'm going to come back over here. And I'm going to scroll down a little bit so you guys can finish writing. Is that good?
Please go up a little bit.
Yeah.
And it's also on page 184.
Yeah, it's on page 184 in the textbook. So if me scrolling up and down is messing you up. And we're going to have an opportunity to fill these out as we do things in the context of the problems themselves. Okay. So I do want to kind of, and this pattern that we discussed yesterday, some of the patterns will emerge again. The first thing we know is that if it's an even power of x, it's going to come in from the top and go out the top unless the leading. Yeah, if you're a 10th grader and you're going on the field trip, see you later. You guys quit playing. You guys are in the 11th grade. Sit down. Nice try. Did you say so I could finish vlogging? Oh, good. Thank you. Who did? I screamed at you? Well, then sit down and be quiet and get ready to learn. I'm screaming at you. What's funny, every morning when I come in, I'm just stalling so you guys could write everything down. Every morning, one of the 8th graders walks by me, and I'm not awake, and this is the look I have on my face. And she goes, "Why are you so sad?" And I go, "I'm not sad. I'm just not awake yet." Yeah, I have one of those angry faces, too. When I'm thinking, this is my thinking face. Ready? My kids think I'm angry when I do that. What's wrong? Are you mad? No? Not yet. Alright, so anyways, I'm going to blow up my calculator so I can take a screenshot. This is the graph. I'm going to move it over here. Remember, we're just plugging in our calculator x to the 4th power. I know you can't see it, but I'm just going to take a screenshot of it. And then I'll copy and paste it into the thing here. So I'm gonna zoom out a little bit. And so this is the first graph. This is x to the 4th power. We're going to do 1, 2, 3, 4 of these things. So I need enough room for all 4. So a lot of the patterns that we discussed prior will emerge. One is, and let me label this so you know what we're doing. This is f of x equals x to the 4th. It's an even power of x, so it comes in from the top, goes out the top. In other words, the end behavior is going to be the same. Now, if I put a negative in front of that x to the 4th, we'd flip it upside down, right? So now we got to look at the factors. Okay, so that's what the graph looks like. We kind of know that, right? We said all even powers of x will kind of have a sort of U shape. Now, as we change it, we're going to do some different things. We can put a couple of humps in the middle, and that's what we talk about turning points. The maximum number of turning points is one less than the degree or power of x. So this could, at most, have 3 turning points. Okay? This could, at most, have 3 turning points, but sometimes it doesn't have a turning point, and that's just based on the function itself. Okay? So let's start. Can I zoom in? Do you guys have all this stuff written down? Okay. So let me zoom in then, and we'll start filling out this chart. Okay? So when we talk about factors, how many distinct factors does this first graph have? Where? I have like tons of it in the thing. Okay. We'll get it later. Let's just focus on learning. It's down under, I don't know where it is. It's somewhere in the class. I'll find it later. So anyways, how many distinct factors? Just one. Okay. And then it asks, what are the x-intercepts? Now remember, the x-intercepts occur when y equals 0. And let me slide over here so we can see the graph. Where do you think that thing touches the x-axis? Huh? Well, what you want to do is you want to pull up your calculator. So let's pull up our calculator. And we're looking for when y equals 0. So just go in and look at the table. And I think 0 for sure. Because mathematically, when I plug in 0, but any other number, you're just raising to the 4th power. So I think 0 is the only one. Okay? So there's that. Oh, I'm on the wrong book. So what are the x-intercepts? They occur when x equals 0. It says, is it tangent or does it cross? Well, I think it's tangent, don't you guys? It doesn't cross. It doesn't go across, so it must be tangent. And it's tangent at what? X equals 0, right? Good, you guys are getting the hang of this. If you can't hear it, they're finishing my sentences for me. That's awesome. All right, now how many turning points does it have? Actually, I think just 1. Now, it could have up to 3 depending on the function, but because we only have x to the 4th power, there aren't a lot of turning points. So there's just one. How many global maximum values? Well, we only have the one local minimum. Well, we don't have a max. So there are 0 local max. The global would be going to positive infinity. We're not gonna write that down, but we do have one minimum, and that's local, and that occurs when x equals 0. And so what I mean by that is when I look at the table of values, and I'm going to blow this up real quick so you can see, this goes on forever. It goes to positive infinity in this direction. The lowest value for y, though, occurs when x equals 0, y equals 0. If I go in the other direction, it blows up. Look at the y values. The more left I go, the bigger those numbers get for the y, right? So, in other words, when I look at the graph, the more I go towards negative infinity, f of x increases and approaches positive infinity. As x approaches positive infinity, f of x approaches positive infinity. The minimum value would be 0. And that's a local. That's a valley, right? So when we talk about mins and max, local mins and max, we're looking for hills and valleys, okay? And that occurs at x equals 0. Do you guys have all of this written down? No? Okay, I'll zoom out a little bit. You just finished? Okay. So off to the side, though, while you guys are writing that down, I'm going to clear out, hit y equals, and if you can, do the same. I'm going to enter in the second equation, which is that x to the third power? Yeah, I'm going to zoom. I got the textbook here. I got to zoom in a little bit so I can see it. So I'm going to say x raised to the third power times the quantity x minus 2. You're finished? Okay. And so let's graph that then. Hey, that looks a little different, doesn't it? So I'm going to zoom out, and let's take a picture of this.
How do I get the colors to go away?
What do you mean, get the colors to go away? I can't see. Oh, bring it here.
So it's just a reset button?
If you hit the reset button, it takes it to factory defaults. That's the easiest thing to do. If you flip the calculator over on the back, there's a little button. You hit that with your pencil or pen, and it just resets the whole calculator to the factory, like it fresh out of the package. I think some of the kids get curious and start looking up how to change colors and stuff, which is kind of cool. But anyways, let's paste this in here. So this is that second equation. I'm going to zoom in because that's going to be kind of a tight thing to write in there. So this is this is the function f of x equals x to the third times the quantity x minus 2. So, kind of keep that in the background. How many distinct factors do you have? Well, I have 1 and 2. So I have 2 distinct factors. The next question is, what are the x-intercepts? Well, to find the x-intercepts, you solve by setting the factors equal to 0. So if I say x cubed, and I set it equal to 0, and I say x minus 2, and set that equal to 0, when I take the cube root of both sides, I get 0 for x. And then if I add 2 to both sides here, I get x equals 2. So at x equals 0, and x equals positive 2. So in other words, it crosses here, and it crosses here. You could verify that on the calculator just by going to the table of values. I got to scroll down now. See? Y equals 0 when x equals 0, and y equals 0 when x equals 2. Okay. Now, what's interesting is technically this is x to the first power, so it will cross in both places. Remember that it crosses when the distinct factors are odd powers. So because this factor is to the power of 3, it will cross at x equals 0, right? Because this is a 3, and technically this is x to the 1, so it'll also cross at x equals 2. Now, if we compare that to this one, this is x raised to the 4th power, which is an even power, which is why it's tangent. It's always tangent when it's an even power for the distinct factor, for the zeros, and it always crosses when it's an odd power for the distinct factor. So you got to keep track of that. We're talking about even and odd powers and the shape of the graph, and then the factors also have an even and odd power, which determines basically multiplicity. Well, I shouldn't say odd powers. It's the multiplicity. Yeah, let's not call it even. It's even and odd multiplicity. Multiplicity occurs when you have the same answer more than once. So it's even and odd multiplicity, not powers. And that occurs, though, when you have x raised to the 3rd power, because you're taking the cube root. In other words, you're going to have 3 of these zeros, but they're all at the same location. This is a multiplicity of 3. And it's multiplicity, not multiply. So I misspoke a little bit. You're like, multi what? It'll make sense as we do more. And if you can't remember all the rules, just graph the thing. How many turning points? Well, now the turning points occur when we go from increasing to decreasing. Okay? So here, it looks like I have a turning point and then another turning point. At most, I would have 3. I don't think, though, and so this is what we got to do, is you got to look where the values change from positive to negative. That's a tough one. Because if it changes, what we're looking for is going from increasing to decreasing. Okay? Increasing to decreasing. And so we really have to look at the table of values for that. I'm going to change the increment because I want to see, so go to second table set and see where it has delta table. I'm going to put 0.1. Okay? And I'm going to start at, I know, 0, so I'm going to start at -1. Whoops, clear that out. It's 0.1 here, and then I'm going to go up here, and I'm going to change this to -1. So now when I hit the table of values, do you guys have that entered into your calculator? I went to second window, table setup. So you want your table of values to start at -1, and then the incremental is going to be 0.1. In other words, instead of counting by 1, it's going to count by 0.1. Okay? And so now, do you have that entered in? Has everybody got this entered in? Now when you hit table, it starts at -1. And what I'm looking for, are the values decreasing? Do they go from decreasing to increasing? In other words, I look at y. Well, it's decreasing, right? It's decreasing, it's decreasing. So as I get to the next value of y, I keep decreasing until I get to 0. Now, is it still increasing or decreasing? Still decreasing, still decreasing, still decreasing, still decreasing. Still decreasing. Still decreasing. Now, I suspect at some point in time it'll increase. So I think right here is where it starts to increase. Well, around there, right? So let's see. Yep, now it's starting to increase. It's becoming less and less negative. So that would be a turning point. And then from that point on, it increases and increases and increases. So we really only have one turning point. And so let me explain what that means by just pulling up the graph. What's going on is this thing is decreasing all along the curve until here. And then it increases. So that's only one turning point. Okay? So, as I mentioned, this is a 4th degree polynomial because when I multiply this out, I would have x to the 4th power. So I could have up to 3 turning points, but in this particular case, I only have 1. Okay? How many global minimum and maximum values? We have global max, it approaches infinity, but we have 0 local max. Comes in from the top, goes out the top, so we only have mins. Now, because we only have one turning point, we only have one minimum, because the minimum occurs at the turning points. Oh, I wrote that in the wrong slot. We have one minimum. Now, we could calculate where that is. It looked like it was about 1.5, but we could actually use our calculator to figure out what this minimum is.
So the minimum is the lowest value?
Yeah. So what happens is when we say local mins and maxes, sometimes we'll have hills and valleys. And so just because you guys are probably a little curious, if I change this, well, let me put it down here so you can see it better. This is a 4th degree polynomial, but if I do x minus 1 times x plus 2 times x minus 2 times x plus 1. Now, this is a 4th degree polynomial because I'm going to have x times x times x. In other words, I'll have x to the 4th power. This is the highest power. I'm going to graph that, and what that does is it changes. Now, at most, I'll have 3 turning points. I don't know if I will, though, because I did squares. So now when I graph that, now I have a minimum here. I'll have a local max here and a local minimum here. But we're going to have a turning point because it's decreasing, 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 increasing, increasing, decreasing, increasing. Does that help?
So that one has 2 local minimum values.
This one has 2 local minimum and 1 local max, but it has 3 turning points. So if you add up the mins and maxes, it's the same number as the turning points. Does that make sense? So where the turning point occurs is where the min or max will be. Okay? Does that help? And that's what we're looking for because later on, like if you're not going to take calculus, it doesn't matter, but basically the mins and maxes occur when the derivative or the slope at that point is 0. On a hill or a valley, if you take the slope at that instant, it'll equal 0. So we're trying to identify them now, know what they look like. So anyways, that's it. Okay, do you guys have that information written down? All right. So now I'm going to take my handy dandy calculator and minimize it. And we're going to go in here. And I'm going to clear this out. And I'm going to clear this out. And so now let's plug in the next equation, which is x squared times the quantity x minus 2 times the quantity x plus 2. Yeah? And let's hit graph.
I didn't get that out.
It's this one right here. Here, I'll zoom in.
Got it.
So I'm drinking my coffee, and I've realized that I like dark roast coffee. My preference is Cafe Du Monde, but I was in New Orleans and they had coffee at Cafe Du Monde, and it was not as good as the stuff that I make at home. Just saying. But it's also very expensive coffee, so I'm trying to find a cheap dark coffee.
I'm more of a tea person.
So that's where I'm at. But when I drink my coffee, this is pretty good, but it's still not quite the same. That was a intermission brought to you by Cafe Du Monde Coffee, New Orleans. So this is the graph for this. Let's take a picture of that. So now, remember I said whatever the degree of the polynomial is, that's the potential for the turning points, right? So let me just paste this in here, and then I'll zoom in and we'll write the function down so you guys can see the actual function. So this one, let me just get over here. This is the graph for the function f of x is equal to x squared times the quantity x minus 2 times the quantity x plus 2. So let's start with the distinct factors. How many distinct factors do we have? 3. Yep, I have 1, 2, 3. Now to find out the y-intercepts, I have to set this equal to 0. So I'm kind of front-end loading. If this equals 0, then I have to think that all of these factors have to be set equal to 0, because 0 times 0 times 0 equals 0. So when I say x squared equals 0, to solve that, I'm going to take the square root of both sides. Remember that when you take the square root of both sides, you do the plus or minus. So x is actually technically equal to plus or minus 0. In other words, you have a multiplicity of 2, x equals 0 and x equals 0. That doesn't make much sense, but it's true. If I take this factor, x minus 2 equals 0, I add 2 to both sides, and I get another 0 occurs at x equals 2. And then lastly, if I say x plus 2 equals 0, then x equals negative 2. And that's a 2. That's the best I could do. All right, so I have 1, 2, 3, 4 zeros. In other words, it crosses here, it touches here twice, and it crosses here. Notice that it's tangent when x equals 0, because I have the same answer twice, a multiplicity of 2. Does that make sense? But because I only have one solution here and one solution here, it crosses completely through the x-axis. So before I move on and we start answering or filling out the table, do you see where it's tangent? Do you see that it has the same solution twice? Does that make sense to you? Okay. So then, let's go up here. So then we have x equals 2, x equals -2, and x equals 0. Those are where it crosses the x-axis. Its tangent at x equals 0, and then crosses at x equals 2 and x equals -2. Okay. Then it says how many turning points? Well, look at the graph. Decreasing, decreasing, increasing, that's one turning point. Decreasing, that's another turning point, and then increasing, so 3. It has one local max and one local min. And I've kind of been blowing this off, and I mean, I'll explain it real quick. It's not that I'm blowing it off. I'm focusing on what I think is important in this lesson. This does have, actually, no, it has 2 local mins. You guys have got to pay attention. Yeah, I said 2 the first time. But the global min can also be the local min, right? So this has a global min, right? And it's symmetrical, so it's going to be here and here, right? So whatever that minimum value is, it's also local min, but it's also global minimums, right? But I'm just kind of ignoring that for now because I want to focus on local mins and maxes. And because that's what you really use this for in the real world. If you guys take pre-calculus or calculus at some point in time, they're going to talk about derivatives. Derivatives are slopes of a curve at an instant.
What is this math like used for in the real world?
This math?
Yeah, like what jobs
So, okay, so that's a great question. Remind me when we finish this. Actually, I might have to stop. Yeah, we'll stop right now, and then I'll answer the question. Well, I could answer it in the video. It's fine. So optimization, a lot of times you have some sort of polynomial that represents behavior. I'll give you an example. Let's say we have some sort of polynomial that represents stock market prices, right? Well, when do I want to buy a stock? When it's really low, at its lowest, a minimum. When do I want to sell the stock? A max. Now, the stock market, a stock will do this minimum and maximum thing, and it'll continue to grow. But there's a lot of people that make fortunes by just buying. It's all math. They have an equation. Now, they've taken calculus. And by using calculus, they can predict when it's at a minimum and when it's a maximum, when x equals this. And that equation also tells them the stock price. So if you ever watch like a finance show and, you know, a guy says, well, the best time to buy is when the stock is at this price. Well, they've done all this math to find out when the minimum is. There's other things too, optimization. Manufacturing companies to optimize the time it takes to manufacture something. We talked about, I don't know if it was this class or the other class, Costco maximizes their shipping. So they contact vendors and say, look, instead of selling us a 24-pack of pop, we want to do a 36-pack because it'll maximize how much we could fit on a pallet and how many cases of pop we could put in a semi-truck. And then what they do is they maximize that space. There's no waste of space when they're taking loads, but basically there's an equation, and we're looking for minimum and maximum. If you want to minimize space, you can have an equation, and what you're looking for is what values of x will I have a minimum y value. This is used a lot for packaging too. If I want to make a box and I want to minimize the amount of cardboard I use, I can make an equation that's the area or volume of the box, and then I could do some math and figure out the minimize surface area of the box in cardboard and still have the same volume, stuff like that. Those types of problems, though, you don't really cover until calculus, because you do have to know and understand what derivatives are. Does that help? Yeah. But just being able to identify them helps too. You don't necessarily have to have calculus to find these things. You guys can plug in the equation on your calculator and let the calculator find the min and max. Okay, that's a good question. There's